Alright, our learning target for this lesson is that students will be able to find the volume of a solid of revolution created if you were to take a function base with cross sections perpendicular to an axis, whether it be the x-axis or the y-axis. So before we get going here, let's just kind of talk about the previous video in which I used some Play-Doh to kind of show you what those cross sections would look like. Remember that cross sections are taken out of a three-dimensional figure, and the shape of the cross section will be given to you in the problem. But the first thing you got to understand is how to go about doing these. So the first thing we need to do is we need to think about the cross section shape, and we're going to figure out the area of that shape. So we're going to figure out the area of the shape of the cross section. And so that cross section might be a rectangle, it might be a square, it might be a circle, semicircle, a triangle, an equilateral triangle. It just depends on the problem. And so you're going to have to know these basic formulas for each of these. And then what you're going to do is you're going to put the area formula inside the integrand, and you're going to go from a lower limit to an upper limit. Well, which is which? Okay? If they're telling you to take the cross sections perpendicular to the x-axis, which means up and down, then we're going to figure out the area in terms of x, and we're going to have our limits, a and b, being on the x-axis. If they tell you to go perpendicular to the y-axis, that means you're going to actually be looking at it left to right. We're going to go right side minus left side. That should sound familiar, to figure out the area. And then these here will be y limits. So let's look at this first one. It says find the volume of a solid whose base is bounded by the graphs of. So what we're going to do is we're just going to graph this like we normally would, and we need to get the actual bottom layer of the base. In other words, what original function would we be looking at? Okay, y equals 2 is right here. Y equals negative 2. X equals 4. And x equals negative 4. So what is bounded by all four of these graphs? Right here. So this would be considered our base. That would be the bottom layer of our Play-Doh. Now we need to visualize cross sections taken perpendicular to the x-axis, so we're going to be going up and down, which are squares. So you kind of have to think of this as being the bottom layer of a square and the other part coming up and out towards you. So what we're going to be doing is we're going to take the area of a square and put it right here. And then our limits of integration are the very left side and the very right side, so that would be negative 4 to 4. And so off to the side, I always like to do this on the side, area of a square is side squared. Well, how long is each side of the square going to be? Well, that's from the top section all the way down to the bottom section. That will be how long the side length is. So how long is that? That's 4 units. So my area is 16. So I need to take the integral from negative 4 to 4 of 16, which means I would go 16x, negative 4 to 4. Then we start off with an easy one because you really can figure out this answer without having to take the integral, but we're going to go ahead and do that. Now again, remember what you could have done is you could have went from 0 to 4 and then doubled your answer because it's the same on either side of the x-axis, or sorry, y-axis. We'll go ahead and do this. 4 times 16. 16 times negative 4, and that would give you 128. And so that's the answer to the volume problem. Another one. The base of the solid is y equals x squared, and y equals 1. This is what I would use using Play-Doh as the base. Now what you're going to be doing is you're going to be finding the volume of the solid if a cross section taken perpendicular to the x-axis would be squares. So now you got to look at this. Squares popping up and out. Little tiny square here, little tiny square here. So you notice that all the squares are not symmetric because this curve changes our top to bottom height. So we're going to take the area put it inside the integral from what to what? Well, we need to figure out where these intersect. So remember how we do x squared equals 1? We set the two functions equal to each other. So they're intersecting at -1 and 1. So we're going to go from -1 to 1. Now, what's the area of a square? Well, area of a square is s squared. How do I figure out how long this is? Remember, that's top minus bottom. So top is 1 minus the bottom is x squared. That's just the side length, and we need to square that whole thing. So if I had to do this one by hand, then I would go ahead and square this, which is the same thing as saying 1 minus 2x squared plus x to the fourth. You need to take the integral of that. We're plugging in a 1 and a -1. So plug in a 1, plug in a 1, and plug in a 1. Minus, plug in a -1, plug in a -1, that would give me -1 times that. -1 to the fifth is still -1. So 1 minus -1 is actually going to give me 2. -2/3 minus 2/3 is actually -4/3. 1/5 minus -1/5 is actually 2/5. So if I get a common denominator, I would get 16 over 15. Now, of course, if this was a calculator problem, you would just type this all in the calculator. Now, in problems like this, it may be easier, I mentioned it in the last one, but I didn't do it, but it may be easier to go from 0 to 1 and then just double it because it's symmetric on both sides. So that would have given me x, remember that, I'm just repeating it from before. And that way I don't need to plug in a 0, all I have to do is plug in a 1. So my common denominator is still 15. If I go ahead and combine my numerators, I'll get 8 15ths. And if I times that by 2, I'll get 16 15ths. Same answer. So what if the shape coming out of this base, we still have the same base here, is not a square, but instead it's an equilateral triangle? And the only thing I'm going to change here, I'm going to go from 0 to 1. I'm going to double it because I just don't feel like doing both sides. I'm just going to do one side and double it. But I have to figure out the area of an equilateral triangle. So off to the side, I'm going to talk about the area of equilateral triangle. You may not remember this one because this is not a common formula, but it's a square root of 3 over 4 times s squared. So I need to do is I need to kind of imagine this equilateral triangle. All sides are equal, right? Well, what's the length of one side? Well, the length of one side is this distance from top to bottom. So I'm going to go square root of 3 times 4 times the side length squared, which will give me square root of 3 over 4 times 1. I'm just going to expand this. I'm distributing. So over here I'm going to go 2 times the integral from 0 to 1 of that problem. Now this is a constant, so I'm just going to bring that out in front. So 2 times that is going to be actually square root of 3 over 2. And then I'm going to take the integral of this problem, which will give me square root of 3 over 2 times x minus 2x cubed over 3 plus x to the fifth over 5. And I'm going to plug in 1 and 0. Plug a 1 in everywhere here. And we already figured out what that one was earlier. That one is going to be 8 15ths. But since we have out in front of there the square root of 3 over 2, these can reduce, and we'll get this. So it intersects at 4, and it's an upside down parabola. y equals 0 is right here. Okay, so here's the base, so I have to figure out what these two are. Well, I could set these equal to each other by hand just as easily as I could hit the intersect button. You would see that they intersect at -2 and 2. So I'm going to go from 0 to 2, and then I'm just going to double it. It's just going to make me a little easier. Or you can just go ahead and type in, since it's a calculated problem, from -2 to 2. Either one. Alright, the cross sections are going to be semicircles, and they're perpendicular to the x-axis, so that's telling us that we can go up and down here to figure out the diameter of our circle. Alright, so the diameter of our circle is the distance from top to bottom. Well, this top function is 4 minus x squared, and the bottom function is 0, so our diameter is 4 minus x squared. But to figure out the area of a semicircle, we need the radius. We're going to go half pi r squared. So the radius is half of this. So half of 4 minus x squared would be 2 minus half x squared. But we need to square that radius. So now what we're going to do up here is we're going to take this whole thing and we're going to put it right here or right here. And if you wanted to, you can actually bring that half pi out in front, because technically that is a constant. But since we're doing this all in the calculator anyways, it doesn't really matter. And then your final answer should be 13.404, since we're rounding to 3 decimal points. Alright, one last one here. It's a circle with a radius of 2. Find the volume of a solid whose cross sections would be perpendicular to the y-axis. We're going sideways, and those are going to be squares. Okay, so right now let's take a look at this. If I was going up and down, I would want everything in terms of x, so I would solve for y. But since I'm going sideways, I want everything in terms of y, which means, what that means is that after the equal sign, I need the variable y. So I'm going to go x squared is equal to 4 minus y squared. I'm going to square root both sides. So that means the right side here, this whole right side would be the square root of 4 minus y squared. And this left side would be negative 4 minus y squared. So when I figure out the area section of it, because remember inside here has to be the area, I need to figure out how to find the area of a square. Well, that's just side squared. Well, what's the side length of my square? The side length of my square is this dimension right here. So I need to go the very right side minus the very left side. Well, the right side is this, and my left side is the opposite. Look familiar? So we're going to add these together. And then because I went right to left here, these must be y limits. So the lowest y value is -2, and the highest y value is +2. And again, I would just bring that 2 out in front. And when you go to type it in, just type it in as an x, and your calculator will do all the work for you.